Okay, we're going to go back and I want to go through some of the homework here on this section 2.2 and just show you the answers and my thought process. Hopefully you pay attention because as you might realize now, this stuff can be pretty confusing, some of the steps. So let's get right to it. This is number 6 on page 41. It's an algebraic, we won't call it a proof per se, but justification of steps. So we start off with this first line, and what's our reason for this line? Well, it's simply given. Pretty simple. That's what they gave us. And then we have to say, okay, well, what happened from this step to this step? Well, I'm looking, I see the 5 was here, it's over here. It looks like they multiplied each side by 5. So my next answer would be the multiplication property of equality. And then what happened from this step to this step? I have to look for my clues. I see the 5's now on the inside over here. This side didn't change, so it has to do with this right here. That is called the distributive property. Pretty simple. Next, I look at this and I say, okay, the 5x is not 3x, the 2x is gone over here. So how did they get from here to here? Well, they subtracted on each side. So they subtracted the 2x on each side. Subtraction, I'm going to write it property of equality. And then my next step, I see the 10 is gone. Negative 10 is gone. It's over on the other side. So they added 10. So this would be the addition property of equality. And my final step, x equals 6, the division property of equality. So pretty easy, these algebra ones, justifying the steps. But it does get you in the right zone. Once again, these links from this one to that one and our reasons. So now we're going to get more to the proof looking stuff. So this is number 7 on page 41. And it's a very, very short proof, but a lot going on that we want to take a look at, especially in the beginning. Let's start with our given statement. AOD as shown. They're basically just saying, hey, here's AOD. That's what they're saying. So that's not much of a given, is it? We're trying to prove that AOD is equal to angle 1. And we might look at that and say, well, it has to be, right? If you add this angle plus this angle plus this angle, that have to equal the whole angle. And isn't that just the angle addition postulate? The answer is no. It's very close, but the angle addition postulate, I want to be very clear, is only 2 angles. If you read it, it basically is, one angle plus another equals, the bigger angle. But it doesn't say that, little angle plus little angle plus little angle equals big angle. It just says little angle plus little angle equals big angle. So you can't use the angle addition postulate right away because it's made for 2 angles, not 3. All right, well then if we can't do that, we have to look at this thing and say, okay, AOD, we have to break it apart essentially, is equal to AOC, there's one angle right there, so they're combining this, plus angle 3. And I don't want to think it's congruent, so I'll put 2 hoops on that. And that does make sense. This angle here plus this angle here equals the whole thing. And what would that be? Pretty simple. Angle addition postulate. So there you're allowed to use it once again because it's 2 angles. Same concept on the next line. They just kind of break it down a different way. We're going to say that angle AOC right here is equal to angle 1 plus angle 2. Pretty easy stuff. Angle addition postulate. Okay, now for this line, this is pretty easy. What we have to, you always know what to put here. This is always the prove line. So we basically just have to write out what we're trying to prove here. So the measure of angle AOD is equal to the measure of angle 1 plus, I'm going to write a measure of angle 2 plus the measure of angle 3. And I'm going to hit the pause here. You got to think this through. How did they arrive at that conclusion? And the way you always want to look, there's only 2 steps, but you got to look at these 2 steps. There's something in there that proves this third line. And look at it very closely. The answer is substitution. It's a very popular last answer, by the way. When in doubt, go substitution. Substitution property. And I want you to make sure you understand where the substitution came from. So what I always did, like I showed you, on the last lesson, is I put little boxes in myself. I do stuff like this, like, oh, AOD was right there. Well, there's AOD. So I see that side. And then, well, where is this angle 1 plus 2 plus 3 then? Well, I don't see that exactly up here, but I do see AOC and AOC, they match. And isn't AOC the same thing as 1 plus 2? It is. So I could say that this right here, I'll put a blue box here. I could input it right there, and that, and it's a little tricky trying to show substitution with boxes, but if you take it slow, it does work. Once again, AOC is the same thing as 1 plus 2, so I can input 1 plus 2 there. And then if you read it, AOD equals 1 plus 2 plus 3. It's the same thing as this. So that would be substitution. And let's look at the last one. A few more steps on this one. We're given that FL is congruent to AT, and notice once again it's already been marked. That's important. If it's not marked, that you mark it. So I would say we'll get right to the first step here, that it says given right here, so we already know FL equals AT. Has to be listed. All right. Now look at this. LA equals LA. Ooh, that's one of those funny properties I always thought was funny. Why do we need it? Well, you're about to find out. This is the reflexive property. Remember A equals A, and I kind of laughed because I never understood why I would need something like this. Of course, A equals A. Of course, LA equals itself. Well, we need it for deductive proof, for deductive reasoning here in this proof. We're going to link it to this statement here on the third statement. FL plus LA is equal to AT plus LA, and that looks familiar to me. Hopefully it does to you. A equals B, C equals D. Now I know these are the same, but this is still C equals D. So then A plus C equals B plus D. This is the addition property of equality. And then we go to our next step. It just basically says that FL plus LA equals FA. So little piece plus little piece equals big piece. That is definitely something that I remember from last chapter. And then the same line, they do it LA plus AT equals LT. Once again, little piece plus little piece, same thing. That is called the, think for a second, segment addition postulate. All right, so we get to our prove line, and we always know, that's what we're going to write in there. It's FA equals LT. And I don't want you to just breeze by because they gave you substitution. Class, it's very important, extremely important, that you look up and figure out where the substitution happened. I could do my old box thing here, or I could just write, and I want you to start writing what steps. And I'm just going to tell you, it's simply steps 3 and 4. I want you to make sure that you start writing down the steps where the substitution happened. It's in steps 3 and 4. You don't even need to look at 1 and 2. The substitution happened right here. Look it through, make the boxes, however it works in your head. But this would be substitution, and I always write it here, steps 3 and 4. So we're going to start writing what steps the substitution happened. It's very, very good thing to do that. I also want to take a few quick mental notes just to save you give you some quick little pointers here. Notice the first line is typically, every proof we've had is just simply the given, and the last line is simply the prove line. So in proofs, you already kind of have the first and last step in most proofs. You will see some situations where they'll give you some more givens, and we'll have to put givens in between. But the reason we do it is to link old statements. But for the most part, your first and last line are simply the given and prove line. And that'll be it for these problems. Hopefully that made some sense the way I explained it. Remember, there's no substitute, no pun intended, for you working with these and honestly messing up and seeing why you're wrong.